And glad to be kicking off this first session for the conference. You're in for a real treat if you are a first-timer here. Martin Durst is a professor at Aoyama Gakuin University in Japan. More importantly and relevant to this conference, Martin is a longtime contributor to the W3C and to Unicode. He actually kicked off. He was one of the leads in their internationalization group. He's published proposals for the domain name internationalization and character normalization. He was the main author of the character model on the IRI specification, and he's been in internationalization for a long time, and has been really key to a number of the proposals and the way the standards work, both for the W3C and for Unicode. So it's a real treat to have you here. Also, if you have been attending previous conferences, Martin has given some of the really fundamental tutorials and outlined quite a bit about how Unicode and internationalization has worked, and it's been the basis of a lot of the talks that we're seeing today based on his work earlier in Unicode history. So, and today he's going to be presenting Ginsu knife, Unicode properties, how you slice and dice them, and given the way people are responding, I think you probably don't know what Ginsu knife is. It's a commercial that was very popular on, or at least frequently presented on TV a while back. Anyway, with that, please join me in welcoming Martin to the conference, and we'll begin. Martin?
Thank you, Tex, for your very nice introduction. I think you set the expectations a bit too high, and I'm not sure we'll be able to meet them, but let's start with this talk. This talk is about Unicode properties. It's online. The address is here. This is the full address, but you have a shortcut down here, and this shortcut is on all of the slides, so you can take your time to actually enter that if you want to check out the presentation online. Okay, so this is the outline of my presentation. We'll shortly look at what properties are, and then the motivation and goals for this work, and then we'll look at more detail about the data that Unicode provides, and then meta properties, and then we should already be done with the talk. Okay, this talk assumes that you have a basic understanding of Unicode, maybe from one of the tutorials yesterday or so, and also that you have an interest in Unicode character properties, which is in many ways a pretty boring subject. Anyway, so here are the speaker properties, properties for myself. I'm from Switzerland. I'm living and working in Japan, but actually this presentation is in Switzerland. There's quite a bit of background there, urgent family matter. I'm here in Switzerland. I arrived yesterday, and I'll go back next week, and then because of the Japanese rules, I'll have to stay in quarantine there for 2 weeks. Also, I had scheduled 2 weekends of coding spikes before this talk, and actually it turned out into more than a week of corona spikes. Just maybe I scared you now. If somebody talks of corona spikes, maybe you imagine the spikes on the spike proteins on the virus that attack your lung cells, but that's not the case. It was just more than a week of, and still ongoing, of checking what kind of certificates you need for entering Switzerland, and for staying in Switzerland, then for going back to Japan, and so on. And it's information that changed all the time, and was difficult to figure out, and so, but I have managed at least half of it, so I'll hope I'll be able to go back to Switzerland. The rest here on this slide, text, already told you most of it. What he didn't mention too much is that I'm also a committer for the Ruby programming language and for the mostly looking for the internationalization part of Ruby. And also I'm a proud lifetime Unicode member. That's actually a lifetime Unicode membership is something that is a thing, and maybe some of you are also already there or will get there. Okay, speakers and properties. What's my relation to properties? I have been working on normalization, where properties are needed. I have implemented various different things that rely on properties. And I regularly update Ruby for new Unicode versions, and that involves looking at the properties in Unicode and how they change and how that affects the implementation. And now I've also had some earlier presentations on property data tutorials and so on. Okay, so properties, what are properties? They are the meat of Unicode, I would say. Why the meat? Well, if we look at Unicode as a sandwich, we have bread at the top and at the bottom and the meat in the middle. And for those of you who are vegetarians, please just replace the meat with vegetables, or if you're Swiss like me, maybe with cheese. Anyway, so at the bottom of Unicode is the character encoding. That's really the most fundamental thing. Which things are characters and what numbers do they get? And then, in order to be used, each of these characters needs a lot of properties. And then these properties get used by algorithms, by things like the bidirectional algorithm, normalization, sorting, and so on and so on, library seeking, and so on. Okay, and so properties are right in the middle here. How to think about properties? Well, it's quite easy. First, we have characters, yeah? And some also unassigned copoints. So we have a character A, omega, the Japanese character for owl, blue, that's the first character in my university, or then also some characters may be represented with their numbers as escape sequences. Then we have properties, something like general category, or script, or age, combining class, and so on. And then for each character, a property has a property value. So let's say we have the uppercase omega, then its script property is Greek, yeah, it's a Greek character. In functional notation, we can take the script property of the character omega and get back the property value Greek. In object orientation, oriented notation, it looks slightly different, but it's essentially the same. Okay, here are some examples. The Latin capital letter A's name, well, is, who would have guessed Latin capital letter A? Well, you might have called it differently, but I just called it that way so that it would match. Then that letter's H is 1.1. 1.1 is the earliest version of the Unicode standard that really counts. So this letter A was there from the start, which is pretty much obvious. Yeah, it's one of the first letters you would put into an encoding. Our omega again has script Greek. Then this little triangle has a name of right triangle. This character here has a property K, Japanese kun, yama. That's because it's pronounced yama. Yama in Japanese. This character here has an age of 3.2. That means it was introduced in version 3.2 of the Unicode standard. And then this code point here, which is not the character, has an age of 2.0 because at that point it was designated as not being a character, especially reserved for not being a character. Okay. Now, this data can be organized in a huge table. And this table here to the right is very small with just a few rows and columns. But actually, you need 1 row per character or code point, so that gives you about 10 million rows. Yeah? And you need 1 column per property. And there are about over 100 properties, so you need 100 columns, yeah? And that means that overall you need about 1 billion, American billion, but that's still enough, quite a lot, 1 billion cells. Okay, and then in each of the cells you have a property value. Okay, so now that we understand the basic concept of properties, how we get properties for each character with their property values, let's see how we actually use it and what we would like to have to make it easier to use them. Well, in my case, I'm updating Ruby for new Unicode versions, and then in that case, I would like to be able to easily access these properties. I have also done research on efficient normalization and case conversation, and also research on the compact representation of properties. If you have such a huge table, you want to somehow find a way to represent it more compactly. Okay, let's look at this updating of Unicode versions for Ruby. Yeah. This is the story. You see, there's a new Unicode version. It was included in a new Ruby version with some delay in most cases. In one case, actually, there was a negative delay. That was because that was of particular interest to Japan. A new emperor was came into office. Maybe that's not the right way to say that for an emperor, I'm sorry. But, and so he needed a new character, and the Unicode Consortium made the formal decision to approve that character in Unicode 12.1 on May 7th, but already on April 17, this was implemented in Ruby and presented at the Ruby Kaigi. Then for Unicode 13, we were a bit slower. And for Unicode 14, I hope to actually use that quarantine time to implement it. Okay. Well, what does this involve? It mainly involves updating property data for regular expressions, case conversion, and normalization. But sometimes that goes extremely smoothly, but sometimes there are some hiccups. Yeah? The particular hiccup was in November 2018, where I needed to update to Unicode 11. And, well, I thought it would just mean running a few scripts, then running the tests, and then committing everything, but no. Extended grapheme clusters were redefined, and some properties just disappeared. And so I asked on the Unicode mailing list, where the real experts are, and then we had a discussion and so on. And then Asmus Freitag, one of the, even all the timers, all the Unicode old timers than me, I'm not sure how old he is in age, but in terms of Unicode age, he is definitely involved longer. He said an index to the plain text Unicode character data, one that lists which properties are covered in which file. Yeah. So a better way to access the Unicode character data was the idea. And that's what this talk is about quite a bit. Okay, then another thing happened when I updated to Unicode 13.0. I found that for the whole emoji testing and so on, one of the files, this emoji, oh, sorry. Let me see, backspace. Sorry. One of the files, this file emoji variation sequences with a lot of data in it, was just ignored. And it took me quite a while to track down that bug, and it had to do with some detail in the formatting of each of the lines in that file that was different from another file, yeah, where I had assumed that it was the same format. Another thing that is ongoing that also plays into this talk is that for Unicode 14, some emoji-related files move around. They are in a different place in the file structure that Unicode offers. And I understand after some email exchanges with Ken Whistler, who is more senior in Unicode than Asmus Reiter, I understand why this is going on, but it's still something that is difficult to track and organize. Okay, so the goal would be to have a data format for information about Unicode properties, which could be used for the analysis of property history, analysis of property data structure, for example, also for compaction, and the generation of code tables for libraries and so on. And that would lead to a generic library to access and process Unicode property data. Yeah? And I have about half of that library now, but not yet the full thing. And that hopefully would also lead to a better understanding of Unicode data publication practices. Okay, so how does Unicode publish its data? Data about properties and other stuff, properties in a very, very wide sense, is made publicly available by Unicode. Yeah? If it's not public, then it's of no use to most people. The data comes in various files. These files have various formats, file formats. It's not so much about whether it's a GIF or a PNG or something like that. It's all, or almost all, textual, but still some files come with semicolons, and some files come with other things, and some files come with many semicolons, and some with less, and so on. And these files are also organized in various directories. And then the files are also available for various versions of Unicode. They're in structured form. Usually it's one item per line, so it's a very simple structure, but still there's quite some details there. And then there's also some textual data. The files contain comments, and sometimes the comments are actually quite relevant. There are also README files. The README files actually have, if you collect all the uppercase and lowercase versions that there are around, there are quite a few. And then what's more important are the technical reports. Yeah, that's but they are all in text, and you actually have to read them to understand them. They are not machine processable. Okay. The data is mostly in the public directory. The public directory is in the Unicode website, the /public directory. Yeah? There, when you go there, you see all the data. I'll just show you that. Here we are. This is this public directory. It mostly has three parts. The first part is all the versions of Unicode. They all say update, update, update. We'll get back to that. The second part is newer versions of Unicode. They're just version numbers. And then there's also other stuff like CLDR, like internationalized domain names, emoji, math, security, stuff like that. Okay, so these three parts, mainly. Three kinds of subdirectories. Okay, so we need this data. What can we do? We want to download it, yeah? But actually, it's a lot. It's a lot. So there's various alternatives for doing that. One is to download every time a file is needed, but that might be too much. I mean, Unicode might not like that. Yeah. Another variant is downloading into a local cache, and another variant is to reload all the files, at least all the files we need. Yeah. The current choice in my implementation was to do a preloading or pre-downloading of most files using the wget command with carefully selected options. I had done an earlier attempt at doing something similar where I had a dynamic downloading, and looking back, in general, the dynamic downloading is probably better because then you only download what files you need, and you can still cache them locally. But for development, it's much better if you separate these steps and you have everything downloaded, and then you can just work on your programs, yeah? And of course, in a final solution, we want to have different options. Where do you cache it? How do you cache? How do you go and check whether we have the newest version or not? There are many different options and trade-offs there. Just if you don't know, the wget command is a very versatile command that allows you to download not only files but whole websites. The command is very versatile. You could actually download the whole public directory with this simple command, but don't do that. This will take too long and will put too much pressure on your machine and on Unicode also. Don't do that, yeah? Because there's lots of things that are, for example, not related to properties, and then you don't need that. There are all the charts included, there's CLDR included, there are many zip files, all kinds of stuff. So you need additional options. Here we have a few of these listed. Exclude some files, exclude some directories. On the other hand, you actually have to, if you are interested in all the versions, you have to instruct it that it shouldn't look at the robots.txt file, because Unicode says to search engines in particular, don't download all the files because we don't want to confuse people with all the data. But in our case, we are very much interested in this all the data tool to understand the history. And then also you should set some randomized wait periods between individual downloads to have a little bit of air and less pressure. And many other options, please make sure if you want to do something like that, carefully read the manual pages. What I did, essentially then run in a bit over 2 hours, downloaded 2,900 files, 466 megabytes in 1 hour and 2 minutes of actual download time. And zero mileage, of course, meltwater. And I downloaded a little bit too much still, but some of the files I had to exclude later. They included, for example, the test files and also sources files, which I at the moment don't consider as properties. It would, for example, for the test files, it would be possible to somehow construct some new theory about properties that they use for testing, but Unicode definitely doesn't look at these as test files. And also then there were some others like README files, diff files, and also the index files like this, for example, the HTML file that shows this directory index. Okay. Then, just so that you know, the latest version of Unicode, excluding a few special things, is actually available in 3 different locations. I'm not sure why 3, but that's it. Now, looking at this data after I downloaded it, I started looking, even before downloading it, I started looking at it. There's many kind of irregularities, you would call them. For example, version directories are not named uniformly. We already saw that. Yeah? The same file might be in different directories in different versions. Yeah? Some file names actually include the version information not only in the directory, but also in the file name. Here are examples of all these 3 points above. So here is an older directory name, here is a newer version directory name. Yeah? Then here is a file with the version in the file name. Yeah? Whereas this file name doesn't have a version anymore. And then the scripts file moved from just the main version directory to this UCD subdirectory. Yeah? So all these things happen at the same time. Also, sometimes there are version information conflicts. For example, there is a version directory 2.1-update3, and the file in there says that it's version 2.1.8. Yeah? What is going on there? What should we believe? Well, why are these things changing? First thing is the number of files increased, and so more structure was needed. Yeah? If you put more and more files all in the same directory, it's going to be a mess. Also, Unicode was learning while running. Yeah? For example, well, they were developing file formats, figuring out what's the best way of processing the data, developing the directory structure, developing the version scheme, yeah? Including adapting to industry preferences. For example, at the same time that many, let's say, browsers and other kind of software suddenly moved to a very quick versioning system that they had a new full version every year, or maybe the browsers even every quarter of a year, Unicode did so too. Yeah? Overall, the latest solutions, the solutions we have now are better, but the change is confusing. And if you want to look at the whole history, you have to somehow figure out how to do that. So how can we deal with these name location changes? The non-numeric part of a file name seems to be relatively stable. That was all actually. It seems to be a very simple, thing, but I was, in an earlier attempt, I was very confused about what should I actually believe? What can I hold on to when processing all these different files? And actually, this seems to be kind of usable. The non-numeric part of a file name seems to be stable, even if the file moves around, even if it has sometimes has a version attached at the end or not. And so in the object, in the class that in the library, I actually expose this part especially with a message so that you can then kind of say, okay, in this version, I want this file. I don't really care in which subdirectory it is. And that seems to work quite well. And other file properties then are, for example, the location of the online version, the location of the cached version, the relative paths below public, the version directory, the file name with and without extension, the extension itself, the file internal version part, and the non-numeric part of the file name. That's what really identifies the file. And then also other meta information like length and so on, and the file contents. So we really have a grab on the file now. Okay. Interesting thing is that the number of files seems to steadily increase, yeah? These are just a few of the versions, but you see it's going up and up, yeah? And that's kind of understandable. Once something like a bidirectional algorithm with its data is established, it won't disappear, it won't suddenly become unnecessary, but new needs turn up, and so new properties and new data is created and exposed in new files. But well, actually, this looks very regular, but if you go back in the history, it's actually more varied. This is the number of files for the first few versions. And you see it goes up and down and up and down. Some cases here are files that were really kind of, they turn up once and then they disappear again. But I think others are cases that, for example, you see the major versions have many files. Version 2 also has many files. And here we have just a few, so I think they just published the updated files, but for those files that didn't need any update, you just go look in an older version. So this also has to be programmed, but it shouldn't be too difficult. Then the naming of the early versions. All versions up to 4.0 contain this update suffix. Why that? Well, this is just my guess, but the really earliest version of Unicode was version 1.0. This was before the merger with ISO 10646, so this looks totally different from what we know as Unicode nowadays. Version 1.1 is the first time where most of the things that were there were in the same position as they are now, the only exception being Korea. So probably people just thought, okay, well, we have an update for version 1.1, and then another update, and so we should make clear that this is an update, so the update turned up in the file name. But at some point then people said, well, we just have a new version, and of course that's an update, and that's, we don't have to spell that out. But there's an interesting other problem, which is that we don't actually know what Unicode thinks about these older versions, yeah? Because if you look at the version page, this is the version page where Unicode describes all the versions, yeah? The newest older version is version 13, yeah, because we are now at version 14, but then if we go back here, 7, 6, 6, let's go 5, 4, oh, version 4.0.0 with corrigendum, that's a very small detail. That's the oldest version that kind of seems to exist for the Unicode Consortium. Not exactly sure why, but, well, history stops at some time. But the data is still around for all the versions. Okay, then the solution I adopted was to just say, well, if something says 1.1-update, I assign that 1.1.0. If something says update 1, I say that .1. That produces only one anomaly in that we jump directly from 2.1.0 to 2.1.2. The alternative would be to go into the directory and say, okay, we take this version here. This would then jump more, and I'm not sure what's the right way. Maybe we can make both available under different names.
Martin?
Okay. Yeah?
I'm just...
I have 10 more minutes.
Yes, that's one of the comments I was going to make. The other, though, is a question for all of these files that are appearing. Is this all normative data? Is some of it just informative, which might later disappear?
Exactly on this
Oh.
slide here. Well, the answer is there's really all kinds of information. Sometimes there's tentative information, just say, okay, this property might eventually be a real property. We just give you some information. This is how it might look. And yeah, that's the provisional, I think. Some is informative, some is really normative. And then even for normative, there's some cases where Unicode really say this is it, but a higher application like a web browser or whatever, an editor, can change some things. And then there are things like names or so where not even that is allowed. So yeah. So these properties and the data, of course, they have different properties. The properties have properties, which means that these are meta properties, yeah? And if you're interested in that, the right thing to do is to read the Unicode Technical Report number 23, the Unicode character property model. I recommend that if you have trouble falling asleep. It's very, very dry. And here is all the different things that it describes about a property. I will skip the details here because it's really very dry. And okay, so how can we get at these meta properties? This technical report describes them, but it doesn't really say which property has which meta property in a kind of complete way. It gives examples, of course. Okay, ideally we would like to get from the data to the metadata with bootstrapping. Just download all the files, look at the files and figure out and say, okay, this property has lots of numeric values and nothing else, so this must be a numeric property. This other property has strings as values, so this must be a string property. But some of these things are difficult to do. For example, Unicode distinguish between enumeration properties and catalog properties. The difference here is that enumeration properties are a closed set. For a certain algorithm, you can have a fixed set of choices, for example, in the bidirectional algorithm or in normalization or so. For some others, you have an open set, let's say scripts, yeah? When a new script is encoded, then the script property gets a new value added, a new possible value. And this is, well, this might be possible to derive if you look at how property value sets change, but it gets more difficult to bootstrap, and intent is this property intended to be changed, or is it normative and you cannot change, and so this is not derivable from the data, yeah? It would also be possible to use scraping. Some data is available in tables. Let me show one of this. This is, for example, this is some table that shows files and properties and some properties of these properties. This would be possible with scraping, although that's not really a very fun talk, a fun job. And the rest needs to be done by hand, yeah. And the next question is how to represent meta property. We could use as domain-specific language. I use, in my program, I use the programming language Ruby, which would make it rather easy to do that. Or we could use some format like JSON, which would be easily interchangeable, or YAML, which is a bit more versatile than JSON, a bit closer to, looks a bit like Markdown, although it's a kind of, well, it's kind of between Markdown and XML somehow. It looks like Markdown, but it has more functionalities close to XML. And then XML itself, well, although that's somehow out of fashion these days. It depends on whom you speak to, of course. Here are some examples. Here is an example of how to describe meta properties as a Ruby DSL. You say, for example, version 12.1, that would be a method call, and then in an argument, in a block, you give all kinds of information, like you have a property name that is in the file Unicode data.txt. In column 2, the type is miscellaneous, and so on. And another property age, which is normative in the file derived age. It's a catalog property, yes, because every time a new version comes on, there's a new property value for this property. The default is no answer, yeah, for call points that are not yet allocated. We don't know what version they will be allocated, and so on. The same information expressed in JSON, it's not, I mean, there's different ways of doing this, but this is just one example. We would have here an object in JSON or a dictionary in some other languages that would say, okay, this is version 12.1, and these are the properties here. There's an array of properties down here, and then the first property has a property name of name. The data is in the file Unicode data.txt, the column is column number 2, and so on, and then the next property. And that would also work. I have recently worked with JSON. One problem with JSON is that if you read the data in and write it out again, the order of these things is just arbitrary. And that's fine for the machine, no problem at all. But for human readers, it's easier to see the property name first here and the version first here. Otherwise, you kind of don't really know what this is all about, yeah? Okay. So having such a format is definitely something that we should try to work on. Okay, so my time is almost over, my talk is almost over. The summary here was properties are at the core of Unicode. machine-readable property metadata would be great. The library I'm working on is progressing, but I need more time. And when I'm done, I'll, or at some step where I think it's usable for others, I'll publish it, of course. And properties come with many exceptions and special cases, and we have to be careful to check the assumptions. Yeah, if you look at different files, you might think they're all in the same format, but then one file maybe has a slight variation, a slight tack to it, and that can be dangerous. Okay, so I would like to thank a lot of people who, well, didn't contribute to this talk, but helped me getting here. And now questions and answers. You can always mail me at this address. Yeah. It's also, if you click down here, you also get automatically get the mail. And yes, and before Tex has a chance to say that, I want to say, please fill in the conference evaluation forms. Please enjoy the conference. I'm really sad that I can't do that with you.
Thank you, Martin. Let's see if there are any questions in the room. Any questions from anyone? So, just for myself, Martin.
Yeah.
So, as you talked about how things changed from version to version, with this file format, though, it's not clear to me how going from version to version is going to be understood by the software that uses it. Because maybe you could say a little bit about that.
Oh, well, yeah, the software, if there's such a, well, the software has kind of two aspects. One is to try to analyze the data and to produce as much of this format as possible automatically, yeah?
Right, so it captures all of it, but the meaning of the changes version to version, right?
Unfortunately, not all of it, but as much as possible, as much as what's automatically possible. And then the data can then be reused, for example, to figure all these things out. Maybe you have to go through all the versions and see, well, there's some commonality, so this property must be this type, yeah? But once you have this information, and once you maybe also have checked it manually, and maybe spoken to some real experts that are above our pay grade still in the Unicode hierarchy, then you can then make it available, and when you run the software again, it won't have to do all the checking through all the versions and so, but you can just say, okay, what's the property, what are the property values and the type of this property in this version, and you get the thing back quickly, and when you actually need the data, it will know exactly which file it has to go, and will go there quickly and only download what it needs. That's kind of the overall idea, yeah. Okay.
Well, we're at time, and we have to allow the room to get set up for the next speaker. So I want to thank Martin for his presentation, and perhaps the people in the room want to thank him, and I'll hold the mic up so that he can hear your response. But thank you, everyone, and we'll get ready for the next session. And thank you, Martin.
Yeah, and thank everybody for listening to such a kind of remote talk. And really have fun and enjoy the conference and get a lot of information out of it.
All right. Thank you, Martin.
Okay.
You take care.
Thank you.
And Martin.